Okay, today's lesson we're doing the Truncus graph, which is a 1 over x squared, or we can write it as x to the power of -2. So if you have a look here, a Truncus graph, you can remember it as looking like a trunk. So it goes up. So as x approaches infinity, so that means as we go out here, along here, we see that x gets closer and closer to y equals 0, y 0. And as x approaches negative, same, it approaches 0, so you get that trunk shape. Okay, so this green graph is a basic Truncus graph. So you can see that x-axis is one of the asymptotes, that's y equals 0, and this one would be x equals 0. So the equations of the asymptotes are y equals 0 and x equals 0 on a basic Truncus graph. If we look at the domain, so the domain is what values x can take on. And if you have a look, it takes on everything but 0. So we can call that the real field excluding 0. And if we look at the y values, the y is always in the positive section of y. So we can write that as like r plus, or we could use our bracket notation, and you can just write, so it's never 0, but it's always above it. So you could write onto infinity like that. Either way is okay. So we'll go over and look at some transformations. Okay, so we're going to look at some transformations here. Okay, in this first example, this -1 here, it moves the graph to the right. So it moves the graph right by 1. So if you think the original asymptote was on x equals 0, now we've got that new asymptote on x equals 1. So there's one equation, asymptote equation. Now we have it moved up and down, so now we can draw our graph. So we've got our truncus, and it would go like this, and it would go like this. Now we would be careful that we've now got a y-intercept there. Okay, so we've got a y-intercept, so you would go about finding the y-intercept by letting x equal 0, and you would find that. I'm not going to do it on this one, but the other asymptote, we're still asymptoting on y equals 0 because we didn't move it up and down. So if we look at the domain for this one, this first graph, we can see that x takes on every value except for 1. So we'll say the real field excluding 1. Now the range is still the same, like it's still going up here, isn't it? So we've still got, it's the positive real field, or if you want to write it 0 and always trying to reach infinity. Okay, so let's have a look at this second graph. So if we look here, this number here, that moves the graph up by 2, so up by 2. So this x equals 0 asymptote's moved up now to, the y equals 0 asymptote has moved up to y equals 2. So we've moved it up, but it hasn't moved left or right. So if we go to draw this truncus here, it will look like that. So if we think of the equations of the asymptote, we have, y equals 2 is one of them, and we still have the y-axis, which is the x equals 0 asymptote. So the domain, we can see it takes every value but 0. So the domain is the range excluding 0. The real field, the real set of numbers excluding 0, and the range is anything above that. So it's not quite reaching 2, but it's always above that. So we could write it like that. Let's do the last one. So the last one, if we look at our asymptotes, it has moved to the right by 2, and this is up by 3. So if we move that, we would have here, and we'd have x equals 2. So there's one asymptote equation, and we moved up by 3. So we've got y equals 3. That's another asymptote equation. And if we go to draw our graph, here we got our truncus, and you can see that we have a y-intercept. So don't forget to find that when you need to as well. So if we look at the range and the domain, so the domain, you can see it's taking on every x value except for 2. So we're going to say the real field except for the number 2. And the range is any number up this way. So we're going to say the real, we're going to say it doesn't quite hit 3, but any number above 3, like that. Okay, so going on to the next page, we've got, now we have a negative. So this negative here, when you have one there, it reflects the graph in the x-axis. So it reflects in x-axis. So if we thought of our basic one, our basic truncus looks like this. So if we're going to reflect in the x-axis, we're going to see it do like this. Okay, so if we have a look, our asymptotes for this one are still x equals 0, this line, x equals 0, and y equals 0. So the asymptotes of the equations are still the same, but if we look at the domain, so the domain is every number except for 0, so the real field excluding 0. But careful, the range is now all the negative y values. So we're going to say, so the largest number it gets close to is 0. Oh, sorry. So the largest number is 0, so that would be the largest. So we're going to see minus infinity would be all the small ones like that. So that's our range. Okay, so we can see from the graphs, when we have this basic formula here, the h, if this sign's negative, that h value will be the x asymptote, and the k will be the y asymptote. Okay, and that's it for today.